Alright guys, I'm going to go over the new factoring technique, which is for factoring ax squared plus bx plus c. It's basically like the last one except with a little twist. So if you're pretty confident with the x squared plus bx plus c technique, well, this one should be equally as easy. So let's go ahead and get started. I think the big key here is you got to follow the pattern. You've got to follow the pattern. The moment you get off the pattern, then you're going to be lost. You need to come back to the pattern, which is kind of tedious, but it's completely doable. And I'd like to show you what basically that means. Is that there is going to be, when we see an M and a P, when we find M and P, we really, regardless of whether they're positive or negative, we need to go place them back into this pattern. This is a pattern because the reason why we need to have this pattern is you got to factor them. Once you get your these terms, then you have to factor them by grouping, and now you have to start making decisions like which one's going to be the P and which one would be best to be M. So you need to make some decisions. So it's really important that you memorize this. So all these patterns that we've learned, you got to memorize them here, because in the end, when we get to down to the quarter exam, it's going to be really tough for you to do it then. So let's go ahead and here get started with our first one. Alright, so we're always going to make this pattern, this T-chart over here, and M and P are always going to be on the left. That's my suggestion in AC. The only difference between the previous one and this one is that instead of M times P, what we're going to be doing is we're going to be taking the by the way, this is your B and your C value, and this would be A. We didn't have an A in the last pattern with x squared, but now they've introduced A here for the first time. So this technique requires that to get the your C value, we're going to need to multiply the C value, which is, let me show you what I mean. So A times C becomes the new C value. So this is A times C, and so B value will, in this case, would be 5, but our C value is going to be this product of 2 and 3, which makes that our C value. I know there's two C's here. One is the value, well, actually, it's the same C right there, except we're just going to call it C. And there it is. So you need to make sure that you're complete. Indeed, the moment you don't do this, it's really going to be a disaster. So please don't eliminate that. Make sure you use that. Okay, here we go. Here's our first example. I'm going to use this, and then I have 2 word problems. I'm only going to do one example with 2 word problems to show you that the level of difficulty is increasing, and we need to stay on top of this here. So here's our first one. We have an A value. I'm just going to do this. We have an A value, a B value, and a C value here, and we're looking for M and P. And the way we do that is we factor. Well, actually, we multiply your A times C. We always start with your A times C, and A times C over there is 6. Now that we have that, we're looking for a pair. I'll just write them out here. It's 1 times 6, 2 times 3, and that's about it. So I'm looking for a factor pair, one of these pairs here that not only will produce a positive 6, but when I add them together, I'll get a positive 5. And incidentally, because the value of A times C is positive, this is a positive number. That means the factors could both be positive or they could both be negative. But we have to look to that middle term. We need to look at the B value, which is positive 5. And because it's positive 5, that means that these factors 2 and 3 have to be positive. So that means positive 2 plus positive 3 gives us a positive value. So I'm just going to go. So now we need to make a decision. I'm going to write the pattern. This is what you should do. Let me go. So here it is. This is a template that you should write. There's just no other way to do it. So I'm going to make a decision. For this to work, if this is going to be my M value and this is the P value, then that means the best one to be my M value would be 2, because here's a 2. I can factor it out. So I'm going to make M my M is going to be value of 2, and your P value would be positive 3. Okay, so we're going to put those on here, and there we go. Put them where they go, because I see that 3 and 3 have something common. So now that we do that, we're going to go ahead and I'm going to rewrite these plus 2x, and we're going to factor by grouping. So I'm going to group those two monomials, and I'm going to take this 3x, put a parentheses, and there should be nothing between these two parentheses, these two grouping symbols. Our next one is 3x plus 3. Let's go ahead and begin factoring. Looks like the greatest common factor of these two monomials would be 2x. So I'm going to factor that out. Leaves us with x plus 1. And over here, Looks like 3 is the greatest factor, GCF. That leaves us with the x plus 1. Remember, we only need, I'm going to go ahead and change the color here. We only need one of these, so we can scratch this one out because this one suffice. And now we're ready to write our factor pair. So it's going to be 2x plus 3 times x plus 1. Check. And that would be this solution there. 2x plus 3, these are the factor pairs that if you were to multiply, you would go back to this trinomial expression there. Okay, let's look at, I think that we have here's your key concept, and you should be really familiar with this. It says the factor trinomials in this form, ax squared plus bx plus c. You do need to find two integers that, two integers m and p with a sum of b, which is our middle value, and a product of a times c. So using a table premium. And then you go through this, then you write them in this form here. This is your form. Oh, here it is. Here's your form. You want to write them in this form and then factor by grouping. Okay, so it's very important. So let's do a word problem. Okay, here's and as I do this, from here on out, when you work a word problem, you need to sketch a picture, because if you don't, it's abstract. You're not really getting any much from it. So here we go. This is always going to be a time to height graph. Here's time in seconds, and here is the height. And it says there's this cheetah, and it's pouncing on an antelope, poor antelope, right? It leaps with an initial upward velocity of 19 feet. So if you noticed, they're not telling us where these values go. So you need to be familiar with this. So it says our initial velocity is 19 feet per second. I'll write it down here, per second. So always should be expressed as feet per second. The question is, how long is it in the air if it's lands on the antelope's hindquarter 3 feet from the ground? So here it is. So here's the initial would be here, and then this is not the path of but this is our time to height ratio, or height relationship. So this is going to be the point that we're looking for. You know, this little cheetah lands on this poor little antelope at 3 feet at this point right here. So there's not a 0 per se on the x-axis as there normally has been. So we need to write our expression. We know that since this is the information we know that the h is equal to the effective gravity, which you need to memorize, plus 19t, because that's your initial velocity. We've defined that, and the initial height would be this point here. It's actually 0, but we're not going to write it in. But you know what? I'll go ahead and write it in. No big deal. It doesn't. It's meaningless unless it's this point. But here's the question. This cheetah is going to land on this antelope at 3 feet. So where does that 3 go? It goes right here. So this is going to be our new height. So it's going to be negative 16t squared plus 19t plus, I'll just leave that 0 there, because now we need to set this side up equal to 0, because that's what we do. We solve for 0. We use a zero product property, so be familiar with that. And here it is. I'm going to go ahead and do that. Let me see if I can get a straighter line. Let's see. I'm writing with this stylus, and it's not that easy. So now we have 0. Hope I can finish it on this side. Negative 16t squared plus 19t minus 3. Here's the deal. So a new change, something to add to something that, our new process. This is a new step. If you look at the leading coefficient here, and I'm going to go ahead and change my color to yellow. If you look at this leading coefficient, it's negative, and the idea is you want to make that positive. And so how do you do that? Well, the multiplication property of equality says if you multiply both sides of an equation by the same value, both sides remain equal. So negative 1 times 0 is still going to be 0, but on this side, this is going to make it positive 16t squared minus 19t plus 3. So we want to make that leading coefficient. You got to remember that. Just got to remember it. So now we're ready to start going to our table. So the first thing we need to do is, hey, through 16 times 3, that's 48. So the C value is 48, and our B value is negative 19. It's okay to use your calculator to look for these here, but I do know that, and by the way, because it's a positive 48, these two can either be positive, these factors, or they can both be negative, because either of those factors would yield a positive 48. However, we got to keep in mind, next thing is look at that b value. It's negative, which means that for that to be negative, then that means that the factors have to both be negative. And so we could go through the process. You can use your calculator, but I already know that negative 3 times negative 16 is positive 48. That means negative 3 plus negative 16 would produce a sum of negative 19. So I've got my factors. We just look at take a peek over here. I see that. Let's write the pattern down. Okay, I said you need to write it down. Let's do it. Here it is. So I'm going to go ahead and put plus, and then in parentheses, this is going to be a t plus another t, and then our last value is plus 3. It's coming right down there. And so these two are given. Now this is going to be my m value and my p value because they're in alphabetical order. So I have a choice to put the negative 3 in this spot here. Or should I place a negative 3 or a negative 16? Well, if I look at this factor, better to put the negative 16 in there. So we're going to put that negative 16 here and the negative 3 over on this side, because it's obvious we can factor those out. So now I'm going to go ahead and do the factoring by grouping over here. So that means 16t squared, and because it's minus, this is going to be minus 16t, and it's going to be times, by the way, I should set this one equal to 0. They should all be set equal to 0 because we're solving. Okay, that's where I take points up. Alright, so the second pair is going to be negative 3t plus 3. And I'm getting it from right here, negative 3t plus 3. We're ready to factor. I'm going to factor out over here on this side, I'm going to factor a 16 and a t out. So if I factor out a 16 and a t, I get a t, I get a t minus, oh, by the way, it's a t here. So that's going to be t minus 1, because that's all that's going to be left. I have to have a value. If I factor out the entire expression, negative 16 or 16t, I've got to be left with something, and it's 1. And over here, I'm going to factor out a negative 3, and that's going to leave me with t minus 1 over here as well. Now, remember, you only need one of these factor pairs, so I'll eliminate this one, and let's go ahead and rewrite this. These are the factors, so it's 16t minus 3 equals 0 is one of them, and the other is t minus 1 equals 0. Alright, so I'm going to solve for t on this side. If we were to solve for t on this side, I'm running out of room, but I'll just see if I can squeeze it in there. I'm going to add 3 to both sides. 16t equals 3. Divide both sides by 16. I'm squeezing this in here. T is equal to 3/16 of a second. Keep that in mind. And over here, add 1 to both sides. T is equal to 1. Let's go back to our graph here. So we've got two positive values. One is 3/16 and one is 1. And these are both time. Well, since they're both positive, that means that the first one here, the lower of the two, this is at 3/16 of a second, that cheetah is zooming past the 3-foot mark. So he at this point right here, he zoomed past the 3/foot mark. But then he comes, this is your time, the height. What's happening is as time goes on, he's coming back and gravity's pulling him back. At this point, t is equal to 1. At 1 second, he will have pounced and beyond that poor little antelope. Poor little antelope at 1 second. So, hey, the value for this one would be t is equal to 1. That's our solution. What does it mean? It means that 1 second, this mean little cheetah is going to be on the back of this nice little innocent antelope. And so there are two roots here. Just want you to be aware of that. The first one, because it's positive, it's 3/16 of a second. Boom, here he is at the 3-foot mark. And because remember, there's two solutions here, and it does cross over this imaginary line here, this at 3 foot twice. Let's go to the next example. Person throws a ball upward from a 506-foot tall building. The ball's height h is in feet after t seconds given by the equation. We've got the equation there. Actually, they're nice to give us this equation. The ball lands on the balcony that is 218 feet above the ground. So here's our little sketch. Let's go and sketch it because we need to know what's happening here. Otherwise, what are we doing? So this is your height and this is your time in seconds. I'm going to go ahead and put way up here. This is 506. Here's a ledge. Here's where that person is. 506 feet. The height is 506. I'll just write it again. 506. 506 feet above the ground, and he throws his ball up, and we know it's going to be a parabolic function here, so it's going to do this, and it's going to come back to ground, boom, somewhere down here. But it's not going to actually make it to ground. It's going to land on a balcony 218 feet above the ground. So let's go ahead and mark another mark. 218 is right here. I'm going to break a boom. It's my estimate of that. So this is actually the point where the ball will land. So let's go ahead and fill in our formula. H is equal to negative 16 t squared plus 48 t plus 506. Alright, so we know the starting point is 506. This is our HO. Our initial height is 506. That's this right here. I'm going to mark it HO because we know that is it. But we know that it's not going to come back to ground. It's going to stop at some point, and so we're going to have to adjust that. So it's at 218 feet. We'll put that right here as our new height. And let's go and run this through here. Plus 48t plus 506. Now we need to set this equal to 0, so we're going to subtract 218 from both sides. Bam, there it is. So we set this equal to 0. We get negative 16t squared plus 48t. And I know that if you were to subtract them, this you're going to get plus 288. Alright. I took a, looks really suspicious here. I think there's a GCF involved because of 1648. I know 16 and 48 have some. So I actually took my calculator out, just like I showed you in class. I found the GCF for all of these, and it's 16. So we're going to factor that out. Looks like this. We factor out the 16. That leaves us with negative t squared plus 3t plus, and I believe this is, I'm going to have to get my calculator again. Let me check. 288 divided by 16. Yep, it's 18. Okay, 18. This is equal to 0. Okay, so we factored out that 16, but we can't have that 16 sitting there, so we're going to apply property of equality that says if I divide both sides by, I need to get rid of it. I need to remove that 16. It's no longer going to be necessary. So if I divide both sides by 16, both sides remain equal. So when I divide this side by 16, these are going to cancel out, and 0 divided by 16 is still 0. So now we have negative t squared plus 3t plus 18. Remember I mentioned that, hey, this is our leading coefficient. We don't want the leading coefficient, and the leading coefficient to be negative. And we know it's a leading coefficient because it carries the greater power too. So we're going to multiply both sides by -1 to remove it. Boom, there it is. So -1 times 0 is still 0, but that makes this positive t squared minus 3t minus 18. Finally, we're at the end, and we have an a and a c value. So negative 18 times, let me just change the color here again. So negative 18 times 1 is negative 18. That means our c value is negative 18. Let's put it in there. We finally got to this point. Our b value is still negative 3. It'll remain that. So we're looking for a couple of factor pairs that, based on this, we know the signs have to be different. That means one of them has to be positive times a negative. The only way you can get a negative by multiplying two numbers is if their signs are opposite. So, but we also have to keep in mind that we have a negative 3 as our b value, which means that the greater of the two, the absolute value, the greater of the two factors has to carry the sign. And I can tell you right now, 3 times 6 is 18. That would have to be negative because 3 plus negative 6 is negative 3. We need them to both produce a negative 18 for C and a negative 3 for B. Got that? Everything's looking good here. So I'm going to try to squeeze the pattern in. I'll do it right here. So now that we know that, it's going to be t squared and plus, and I'm just going to go ahead and put this in here because, and it's t plus another value of t, and then our last term is minus 18. So we keep these two, minus 18, boom, goes right there. Our first term, t squared, boom, goes here. So now we're ready to take these. I like to place this 6 in with this 18 over here, so I'm going to place that negative 6 there, and that means this 3 will come over here. So here's our factoring by grouping. That's going to be the technique. I will go with this orange color. So now we have t squared plus 3t times negative 6t minus 18. And we're going to factor out, it looks like the only thing I can factor out from this expression is a t, which will leave us with t plus 3. And over here, I will factor out a negative 6 because that'll leave me with t plus 3. And since we only need one of these factors, I'll just eliminate this one, don't need you. And so we have our first binomial pair. I'll just write it over here. That's going to be t minus 6 equals 0. And the other is going to be t plus 3 equals 0. T plus 3 is equal to 0. Let's go ahead and solve. I'm going to add 6 to both sides. One of the times is equal to 6 seconds, and the other one, add negative 3. One of them is equal to negative 3. So obviously this one will not, can't have negative time. It's out. So that means that the time that the number of seconds it'll take, I'll just write it here. For this ball to be thrown from a height of 506 feet before it hits and lands at 218 feet platform, it will take 6 seconds. And there it is also, bam. You know, later on we'll talk about what the significance of this negative 3 is here, and there is a significance to it. So, but we'll share it at another time. It's not important right now. Hey, these are the type of problems that we're going to be working. Now we start using that projectile motion formula. We need to know it's from inside and backwards. You know, we just need to be solid with it in order to be successful, because yes, they do get increasingly more complex. And so please, I'm encouraging you to, you should be summarizing your lesson in your interactive notebook. That's your responsibility. And watching my videos when I publish them so that you can, get reinforcement. All right, good luck. We'll see you in class. Thanks for watching.